Zealandia breaks almost every rule of what a continent is supposed to be. Nearly all of it has no deserts, no ranges you can drive across, no rivers running down to a coast, and no dry interior at all. On a standard world map, it does not exist. Yet it is a single coherent slab of continental crust, roughly 2/3 the size of Australia, sitting in the southwest Pacific, with about 94% of it underwater, most of that around a kilometre down. Whether that makes it the 8th continent or something short of one is still argued. What it is made of is not. The 6% that is dry land you already know under other names. New Zealand is the largest piece of it. New Caledonia is the next. Lord Howe Island, Norfolk Island, and the Chatham Islands are most of the rest. Together, that is under 300,000 square kilometers of land, standing on 4.9 million square kilometers of continent. This is not a curiosity of naming. New Zealand's exclusive economic zone covers about 4 million square kilometers, roughly 15 times its land area, and in 2008, a United Nations Commission confirmed its rights over a further 1.7 million square kilometers of seabed beyond that. Those claims were argued and won on the question of what the rock down there actually is. The continent pays out in other ways too. New Caledonia sits on one of the largest nickel resources on Earth, and the reason is geological. About 34 million years ago, a slab of the Earth's own mantle was pushed up out of the seafloor and driven bodily over the top of the island, and tropical weathering has been concentrating metal out of that rock ever since. Which brings up the awkward part. Most of us learned the continents as a list to be memorized. 7 items, fixed. But there is no international body that ratifies continents. No committee votes them in. The 7-continent model is a geographic convention, and conventions are built for people, not for crust. A geologist asking whether something is a continent is asking a different set of questions. What is it made of? How thick is it? And where exactly does it stop? To answer those for Zealandia, you have to go back to Gondwana. For most of the Mesozoic, the rock that is now New Zealand sat on the eastern edge of that supercontinent, wedged between Australia and Antarctica, on an active margin where ocean floor was being driven down beneath it. That subduction built the basement, a long belt of granite geologists call the Median Batholith, the arc that welded Zealandia together in the first place. Then the margin stopped swallowing ocean floor and started pulling apart. From roughly 105 million years ago, the eastern edge of Gondwana went into extension. Around 85 million years ago, Zealandia broke free of West Antarctica, and the Tasman Sea began to open between it and Australia, unzipping from south to north until spreading stopped about 52 million years ago. That separation is written into Australia itself. Rifting cut a new eastern coastline, and the escarpment along the seaward side of the Great Dividing Range has been wearing its way inland from that torn edge ever since. The Tasman Sea is the gap Zealandia left. If you have ever wondered why Eastern Australia drops off so abruptly into the sea, this is the answer. The other half of that landscape is out there, underwater. Close the Tasman Sea in a plate reconstruction, and the Lord Howe Rise slides neatly back against Queensland and New South Wales. So why did it go under? Not the way a ship sinks. Stretched continental crust gets thinner, and thinner crust floats lower. Normal continental crust runs 30 to 46 kilometers thick. Zealandia's runs 10 to 30. It was pulled out until much of it was little more than half the thickness of the crust it broke away from, and then, as the hot rift zone cooled and contracted, it settled. Its most common elevation today is about 1,100 meters below sea level. It did not collapse. It was drawn out until it went under. And that is precisely why it still counts as continental crust rather than ocean floor. In 2017, Nick Mortimer and 10 colleagues laid out the case in the journal GSA Today, tested against the 4 working criteria geologists actually use. 1. It stands high above the ocean floor around it by more than a kilometer. 2. It is made of the right rocks, a broad range of silica-rich, igneous, metamorphic, and sedimentary material, granite and schist and sandstone, not the basalt that floors an ocean basin. 3. Its crust is 10 to 30 kilometers thick against about 7 for an ocean basin, and seismic waves crawl through it more slowly. 4. It has well-defined limits around a single area far too big to file under microcontinent. 4.9 million square kilometers is half as big again as India. None of that was ever obvious from the surface.
It had to be assembled from satellite gravity maps that read the shape of the crust through 2 kilometers of water, from seismic surveys that time shock waves through the rock to measure how deep it goes, and from decades of samples hauled up 1 bucket at a time off the seafloor. Here is the genuinely strange part. A continent larger than India sat unmapped into living memory. The name Zealandia was only proposed in 1995 by the geophysicist Bruce Lyondike. The reconnaissance geological map of the whole of it was not finished until 2023, when Mortimer's team published the basement geology of North Zealandia in the journal Tectomics, built partly on rock dredged off the Fairway Ridge in the Coral Sea by a research vessel dragging a steel basket along the seabed on a wire.
Most of Zealandia's map is written in names almost nobody outside marine geology has heard. The Lord Howe Rise, the Norfolk Ridge, the Challenger Plateau, the Chatham Rise, the Campbell Plateau. Those are not seabed features in the ordinary sense. They are the highlands of a continent, drawn in depth contours instead of shading. That paper closed the last blank. Te Riu-a-Māui, the Maori name now carried by the continent, the hills and valleys and plains of the ancestor Maui, became the first continent on Earth mapped in full, onshore and offshore. We had finished geological maps of the whole moon by 1979. Not everyone accepts the promotion. The objection is not that the crust has been misidentified. Nobody disputes the rock.
The argument is about where the line sits between a continent and a microcontinent, and because no authority defines that line, it cannot be settled by evidence alone. Some geologists still prefer microcontinent or continental fragment. Richard Ernst has called Zealandia a gray zone case and floated mini-continent as an honest middle term. It is a dispute about vocabulary, standing on top of data everyone agrees on. There is a second argument, and it is older and sharper. Around 25 to 23 million years ago, Zealandia sat at its lowest, and the land above water shrank to something like 18% of New Zealand's present area. Some researchers argue it went under completely. If it did, then every plant and animal in New Zealand arrived afterwards, by sea or by air, and nothing living there is a Gondwanan survivor. Most of the rock record now points to at least some land holding on, and genetic work on beetles, soil invertebrates, and trees keeps turning up lineages that look older than the drowning. But whether this continent has ever been entirely beneath the waves is still not settled. Which leaves the last question: why is any of it dry at all? Because a new plate boundary tore straight through it.
Over the past 25 million years, the Pacific and Australian plates have ground past each other across Zealandia, offsetting it by roughly 500 kilometers along the Alpine Fault, and in the last few million years, buckling up the Southern Alps. Aoraki, Mount Cook, stands 3,724 meters above the sea. That is not an island peak. It is the high point of a drowned continent, shoved back into the air by forces that have not finished with it. So New Zealand is not a scatter of islands in an empty ocean. It is the 6% of a continent that happens to be above the waterline right now, and the waterline is the least permanent thing about it.
Zealandia was never lost. It was simply sitting below the level at which we were looking, and it took until this century to accept that a continent does not have to be dry to be a continent. If you want more deep-time geology from this corner of the world, there is plenty more on the channel.